Dave invests $1,000 into an account earning interest at an annual rate of 3.4% compounded annually. 3 years later, he finds a better investment opportunity. At that time, he withdraws his money and then deposits it into an account earning interest at an annual rate of 4.3% compounded annually. Determine the value of Dave's account 10 years after his initial investment of $1,000. So one thing that makes this problem a little confusing is we have two different interest rates, and we need to figure out how to use those rates. So fortunately, both of those rates are annual rates, which will make some of the calculations a little bit easier on us. But to see how to use the two different rates, let's draw a time diagram. At time 0, Dave invests $1,000. We want to know how much money he has 10 years later, 10 years after the initial investment, so that's at time 10. For the first 3 years, his money is in an account that earns interest at an annual rate of 3.4%. So that would look like this. That would be his R. And he earns that rate for 3 years. Once he hits 3 years, he takes the money out of the account and then deposits it into a different account. In the second account, he earns interest at a rate of 4.3% every year. Okay, so this diagram should give us enough information to be able to solve this problem. A couple things I'll note is that, one thing I'll note is that M, the number of compounding periods per year, is 1 in both cases because we are compounding interest annually. So let's start by trying to figure out how much money Dave has at the end of 3 years. This turns out to be pretty simple. The accumulated value after 3 years would be his initial investment or his initial principal times 1 plus I. Now in this case, since we're compounding annually, I is actually equal to R and is 0.034. So 1 plus I would be 1.034. And then he leaves money in this account for 3 years, so I raise this to the third power. Okay, so I calculate that, and I get $1,105.51. After 3 years, Dave's account is worth $1,105.51. So this is when he takes that money out, then reinvests it into a different account, and then leaves it there until 10 years total have passed. So now, I want to figure out how much money he has at time 10. So, I want to figure out the accumulated amount, and I know that the initial investment for this second account, actually let me clarify something real quick. I don't care at all about what happened before time 3 now. For this second part of the problem, I am only interested in this time period. So, the amount invested for that second stretch of time would be the $1,105.51. So that is my new P, 1105.51. The interest rate on the second account is 0.43. Now I don't need to divide R, I divide it by 1 since I'm compounding annually. So R and I are the same here. That's not usually the case. Now, it's tempting maybe to want to put a 10 here as the exponent, since I'm going to time 10. But that's not true. That's not correct. Notice I'm starting at time 3 and going to time 10, so that means a total of 7 years will have passed. Dave's money will be in the second account for 7 years total. So, I can calculate that number, and I get 1484.40. So this is how much Dave has in the account at the end of 10 years.